But
can we
if,
oh, I'm sorry. Go.
oh, you know, go ahead.
Oh, okay. Can we use like strings? For example, new string and then 10 and then down there system out frontline data and then some sentence.
You like, yeah, there could easily be string data type values in each of these cells rather than integers.
Okay, thank you.
Whoops, okay. This is kind of saying more of the same. Oh, no, this is actually a little different. So, okay, here in the top, we're saying, so numbers of 1 equals 3. So we're putting the value 3 into this spot right here, the address location 1. So think of it as the value on the right side of the equal sign is being put into the location on the left side of the equal sign. But in this example here, int x equals numbers of 1, where we're kind of, it's almost like we're taking the value out of the array instead of putting it in the array. So numbers of 1 is the second address location. So the value there is 4. So then the integer x variable would have the value 4. 4 would still be in the array at the spot numbers of 1, but we're taking the value that's found at numbers of 1, which here is 4, and we're putting it into the integer x. So these are just kind of examples on how to reference values when we put the values into the array or copy the value out of the array. Okay, so this is a standard for loop for navigating, looping through a simple array. So in the first example, we're outputting the values. So for int I equals 0, I is less than 8, I plus plus, system.out.print numbers of I. And all that's doing is looping through the array, starting at position 0 and continuing as long as the position address value is less than 8. So it'll go where the integer is 0, the counter is 0 up through 7. Now here, they know the value, they know the length of the array is 8, so they can just flat out hard code that in the code and say, loop as long as I is less than 8. It would actually be probably better style to say while I is less than numbers dot length. And then that would automatically kind of capture the length of the array. Here they just know the length is 8 and they've hard coded that value right into the code. So here's that example, what I just said. So, and this is really better design. So for int I equals 0, I is less than numbers dot length, I plus plus. It's just kind of cleaner. It reads better, right? In the first example, 8 happens to be the length of the array, but I mean, who knows? If this isn't a huge program, maybe 8 is something else. Maybe 8 is like, I mean, who knows? Number of whatever, evaluation periods or whatever. So
excuse me?
Yeah.
Why is the quotation mark after plus 4? Is it for like leaving a space?
Here?
Yeah.
This plus mark right here?
I mean the quotation mark.
Oh, why is there a space there?
Yeah. No, I mean the quotation mark after add. like number I add quotation mark. What is it for?
I kind of lost you. So sorry, where?
The I don't know, quotation mark.
On the second line right underneath numbers length, like right where your like cursor's
Yeah.
blinking, like right,
Right now
Oh.
you're
and to the right.
Oh, so right here.
Yeah.
Yeah.
I believe it would work fine either way, but what they're adding here is the white space in between the values when it's output. Because without the plus quote space quote, the numbers would output all together like that. But we can test this. I'm pretty sure this would execute perfectly fine if we just went like that. It's kind of more a style thing. That looks a little more cryptic than if we go like this. Okay, let's see here. That's a code question. We'll get into the code here in a minute in Eclipse. Okay, so what this is illustrating is when we declare an array, we also have the option of just like auto-populating it right off the bat. So rather than just say, well, I'm going to declare an array of integers named numbers, and it'll be length 7. We can actually put the values in it immediately. So here we declare an array named numbers of integers, and we're just flat out saying, and the values are going to be 12, 49, minus 2, 26, 5, 17, minus 6. So just know you can do that, but understand also that you're hard coding those values in, right? So those are not going to, well, they could change in the array, but I mean, in the code, those numbers are hard coded in. They're not really going to change in the code like a variable would. Any questions about that? And the thing to watch for there is the curly braces. So here, we have int brace numbers equals curly braces and then the values. And this could be done with strings too. If it were strings, then you'd have like the string inside double quotes. But it, of course, with a simple array, all the data types have to be the same. So then they'd all be strings. Or with a char, they would all be, single apostrophe quotes with something like that. I'm not going to do that. Limitations of array. Okay. So simple arrays cannot be resized. So once we declare a simple array and we say length is 10, it's 10 for the whole program, basically, with the simple array. Later, when we talk about array lists, those are dynamic. We can dynamically add a value, remove a value, and the length changes dynamically, which is really cool. But this is like, I don't know, you're buying a car or a bus, and if they say it seats 5 people, it seats 5 people. You can't really change it. And then also with variables, we can compare the values using the double equal signs. That doesn't work with arrays. So here we have 2 arrays, A1 and A2. They're both arrays of ints, and they both contain the exact same values. We cannot just say if A1 equals A2. Because that's not actually seeing the values. You would have to inspect, you would have to loop through and compare the individual values one at a time. And there's no, you can't just print out an array. You can't just, so here you can't just say, well, system.out.println A1 for the array A1. That would probably print the address in memory, which would look like gobbledygook. There is a built-in method called toString, which will simply print out the array contents as a string, but it just kind of prints it out as one long laundry list string. And these are other methods that are included with the array library when we use java.utils. So there's a binary search, copy of array length returns a new copy of an array. Here is an equals method that will compare. It will return true if the two arrays contain the same elements that are in the same order. But you have to use this method equals. And then there's fill and sort. Binary search, by the way, is essentially when you play that game of like pick a number between 1 and 100. And so you choose the midpoint, you say 50, and they say lower. So then you take the lower half, you choose the midpoint of that, say 25, and keep slicing and dicing each half until you find the value. That's binary search. That, of course, is going to be quicker than just starting at one end of the array and going to the other end like a linear search. But it's not as fast as some search methods that you'll study next quarter in CS211, which are more efficient, like, oh gosh, now I'm spacing on the names. For sorting, there's like bubble sort and insertion sort. Now I'm completely spacing on the name of them. But binary search is faster than a linear search, but not the fastest search method. The other thing too, the data has to be sorted for that binary search to work. So like in that game where you pick a number between 1 and 100, right? The values are sorted. Okay, any questions about those methods before I go
on? Excuse me, teacher, did you record the class?
No, thanks. Okay, thanks. So here's the arrays to string example. So E, an array of ints, has these values 0, 2, 4, 6, 8. And then we could use a println statement. E is, and then I'll call arrays to string and pass in the object E, which is our array of ints. And it would just output simple list of the values. And again, you must use java.util to use that. Whether I'm not going to use this, well, let's see. Okay. So let me see if this has a good example of this. No, well, so the call out here is that arrays can be parameter arguments to methods. The most famous example of this is our main method. So I think we went through this in on the second class day. The main method, again, is public static void main, and inside parentheses is string brace brace args. And remember, this is the array of strings, which are the command line arguments for the program. So in this case, an array of strings is passed in as a parameter argument to the main method. But we already talked about the main method, but just remember though that arrays can be passed in as parameter arguments to these methods. I'm not gonna that. Let's see. I'm going to go through some code examples in Eclipse. I'm going to skip over this stuff. I'm not gonna. These are the some of these slides that I don't use. I need to just remove from the stack and create a second deck. Okay. So this is also calling out that not only can simple arrays be parameter arguments in the methods, you can also return an array from a method. So here, it's merging the data values in the array. Result is an array of ints. And at the end of this method, it returns the array named result. So it accepts two integer arrays as arguments, and then it returns a different array that has the merged results. So the simple arrays can be both parameter arguments and they can be return values from the methods. Multi-counter. I'm not going to use this solution. Okay. These are slides from this alternate Woo text, which I really like, but I think we've covered. Yeah, we've covered everything in here. I'll talk about the same topics as we go into some sample code. So, okay, let me show you some sample programs of simple arrays, and then I'm going to talk about class objects, and then we'll walk through some code that uses arrays of class objects. But before we get into that, let me just walk through some simple array code examples here. So let's see. Okay. Okay, can you see the code clear enough?
Yes.
Because I can make the font bigger, but then we kind of run out of real estate.
It's all good.
Okay, so let me run this program one time just to show you guys what it's doing, and then we'll walk through the code a little bit. Okay, so prompts me, how many numbers do you want to input? I'll say 5. Please enter a real number, 3, 1, 8, 6, 4. Okay, and it calculates the standard deviation of those numbers. Okay, so let's just walk through this code here for a moment. So this program has one class file, just one. It's called exercise 1011. This is from a different textbook, that Woo textbook. So don't worry about that exercise name. Again, the name of the package has to match the name of the package in my Eclipse compiler. I import java.util. Here's the name of the class. Then the class begins there. Then immediately we start with the main method, right? Public static void main string args. They declare a scanner object. This is standard syntax right here. Scanner equals new scanner system.in. The name of the scanner object could be whatever we want to call it. But oftentimes these textbooks will just name it scanner with a lowercase s. And there's a yellow warning there, I think, because it's never closed. We could add that. In a larger program, that could cause like a memory leak, but in a smaller program like this, it's not really an issue. So they declare integer n and set it equal to 0. And that's used when they prompt the user how many numbers you want to input. So n equals scanner.nextInt. So that was the, what did I put in, 5 or 6? User input gets put into the variable n. So now they declare a simple array named number array. It's going to be of type double because the standard deviation answer will be a decimal value. Equals new double brace n. So they're creating an array of whatever size the user entered. Okay, any questions about that so far?
Is number array just like something the programmer wrote?
Yeah, that's the name. That's just the name of the array. This could be anything you like.
Okay, thank you.
Yeah. Okay, so now there's a standard for loop for int I equals 0, I is less than n, I plus plus. And so they loop as long as I is less than n. So they're looping whatever number of values the user indicated they wanted to enter, that's how many times we're going to loop. And it says, okay, so please enter a real number. It loops. They use scanner.nextDouble because we want to capture the decimal values if they enter that. And remember, as you enter, as you type scanner and hit dot, in Eclipse, it'll bring up all the different methods that you could use. So scanner.nextDouble, and then they put the value. So this is the value that the user has typed in each time. They put that value into the simple array at address location I. And remember, I is getting incremented. So all they're doing is looping through the array, prompting the user to enter a number. They take that number and they put it into the array, and then I gets incremented to the next spot.
How would this look like if we used while instead of for?
So a for loop, we know how many times we need to loop, right? It's one less than the length of the array.
Yes.
With a while loop will continue looping forever as long as some condition is true. So we could make a while loop work, but we would just have to make sure that it stops at the right time. So we might say while I is less than n, and then increment I, and that would probably work. But typically while loops are used in scenarios where we don't really know how many times we need to loop. It's more of a environmental thing where we continue looping until a certain event happens. But here, we know exactly how many times we need to loop. So a for loop is kind of a more simple way to do it.
I see. Okay, thank
you. Okay, so now they declare an average variable. They just set it equal to 0. And this is going to be used to hold the average of the values. And now we're getting into the formula for standard deviation, which I actually don't remember what it is offhand. But first they calculate the average. So they loop through for int I equals 0, I is less than n, I plus plus. And they take the value in the array at position I and add it to the variable average. And as they loop through, this is producing a running total. So when they get to the end of this for loop, now you have the grand total of the values. And then they calculate the average. So average equals average divided by double n. So here, n, remember, is the number of values. And the double keyword here, they're actually typecasting n to a double, because remember, n was an integer, but now average is going to calculate the average. Is going to probably end up with a decimal result. So we need to typecast n from an int to a double, because now we're going to be using decimal calculations, and we need it to be the same data type. That's kind of a side note to this. You could argue that, well, why didn't they just create n as a double to begin with? That possibly might be better design. You could argue maybe. And then now they're calculating the standard deviation and putting the value into the variable result, and then they output it. So this is a pretty good example of just using a simple array of values, as well as like looping through it. So any other questions about this code? Okay, 10:32. Okay, let me run this program one time, and then we'll walk through this. Okay, so this has a list of pay scale steps, I guess, and it's simply calculating the average for each grade and steps. And again, you can see here's the beginning of the class, then the beginning of the main method. Then they declare, here they're declaring a multi-dimensional array, like we're using for that latest assignment. And they're just setting the values right off the bat, right? So here's kind of the grid of values. They're using the nested for loop to navigate through and loop through, and they're calculating average for every grade level and average for every step. So I think they're getting average of each column and row, and then outputting it. So really, the main thing I would call out here, remember with a multi-array, it's also zero-based, but the row and column numbers start at the upper left-hand corner. So this is row 0, and then row 1, row 2, row 3. And then this is column, oh, it doesn't really highlight that way. This is column 0, column 1, column 2, column 3, column 4. And to reference the value at each address location, now there's 2 coordinates, I and j. So I is the row, which is used with the outer for loop counter, and j is the column, which is used by the inner for loop. So pay scale of ij is the coordinate position within this grid.
When you wrote that like double sum equals 0.0, is there like a huge difference between writing just a normal 0 or like or this 0.0?
You know, I think this could be, even though you have a double value, it would be perfectly fine to just say sum equals 0. I mean, it's a double variable, so that will equate to basically 0.0. I'm not sure why they wrote that. It's almost just like a style thing. I mean, 0 is 0. So both of those values equate to 0, you know.
Yep.
Okay, so any questions about simple arrays at all? Because now I'm going to talk about class objects and classes. Well, I'm going to show you this just so you know what it is. This is technically array lists will not be covered until next quarter, CS211. But I at least want to kind of introduce them to you and so you know they exist. So this is an array list. And it's the same example as before, but it's dynamic. So, so they ask, how many numbers do you want to input? And then they declare array list of type double, number list equals new array list double. And the array list is a class built into the language that we can use when we import java.util. And it's the funny thing is it's easier basically to use than a simple array because it has all these methods built into it. So here's the name of our array list. We're naming it number list right here. So when you type number list and then hit the dot, it brings up all the methods that are automatically included in the array list class. And so this includes add, contains, remove, get, index of. So it's really easy to search, sort, add, remove, all that stuff. I mean, the methods are already written for you. So remember in our simple array code, it prompts the user, how many values do you want to enter? I entered like 5. And so it says, okay, then I'm going to create an array of like 5. So here, well, they kind of do it here with n, but you wouldn't even need to because you can use the add method to dynamically like add on to the array list. So let me just run this. It's basically not going to look much different from the simple array from running. So I'll just do this quickly. So 3, okay, 1, 2, 3, and it computes standard deviation. But I don't know, this code, even though array lists are maybe slightly more complex than a simple array, I think they're actually easier to use because they have all these methods like add and remove built into it. So for now, just know that they exist. If it's perfectly fine to use an array list for assignments, or if you do the extra credit with the video game assignment and use an array list, that's fine for now. But mostly just know about them. Okay. Okay, how are we doing on time here? 6:30. Okay, let me talk about classes and class objects because I'd really like to kind of get into this topic because we're going to start running into the classes more and more. Excuse me for 1 minute here.
Are we going through 2 chapters this week?
Yeah, I'm covering it, but this is kind of for next week too. There's no quiz on this week or anything, but because of the holiday Thursday and the schedule next week, I'd like to at least get into this today.
Oh, okay.
Okay. Okay, so with classes and objects, we really start to get into the new object-oriented component of Java. So let's see, where do I start here? So with classes, it's a collection of like data and associated methods that are related in terms of the design of the objects in the program. So for example, if we were designing a program for like a GPS system in a car, that you would look at at a high level what the different classes would be. One class might be the driver of the car, the user, the operator. Another class might be the map itself or the city that we're in. And then there may be other classes pertaining to kind of the logic, like for instance, a navigational class, which has methods to determine the best route, or a traffic data class that contains the updated traffic data. But each class would contain data fields and methods related to that class. So if there was a class for the person, for the driver of the car, there may be certain settings for their preferences, and those preferences would be saved maybe in that class. So maybe I like the background to be black. I like the brightness to be dim. I might like a certain font. What else? Preferences. I prefer freeways or avoid freeways, or prefer toll bridges or avoid bridges, and so forth. So it's a collection of data fields and methods that are related to each other. So here, this is kind of using like it's kind of a graphics program, but they have public class point. And the point class has two data fields, int x and int y. So those would be like the coordinates of the point, probably more in a traditional sense, like x and y coordinates. Here's a class, public class student. So a student class may have two data fields, string name and double GPA. So these are data fields that pertain to that class. So, if this is like an enrollment program, there may be another class like classroom, and classroom may have a data field named capacity or number of seats, and that might be 30, right? The number of seats data field would be in the classroom class, because if we were to put capacity or number of seats here in the student class, it wouldn't really make any sense. That the number of seats that the classroom has really nothing to do with the student. These data fields should all be attributes of the student itself. Any questions about that? Okay. And we'll look at code examples of this shortly here. Okay, so remember with our point class, so slide 15, that was back here. We have our class point, and we have, that class has two data fields, X and Y, right? Here in this program, we say point P1 equals new point P2 equals new point. So what they're doing here, they're creating two objects of a point class. And once we create an object of those classes, that's what we reference. So this is, I think I gave that analogy of like a airplane seat. You might have a seat on an airplane named 12B. There's nobody in that seat. Once somebody sits in the seat, now it's might be, you know, Mary Smith or something. Or you might have a license plate at a DOL office. It's not registered to anyone. Somebody comes by, they register their car, they pick up the license plate. Now that license plate is actually registered in a specific person's name. So when we create an object, so here we have P1 is an object of the point class. The object now will contain all the data fields that the class contains. So the class has data fields X and Y. So now our object named P1 has data fields X and Y. So we can reference P1.X and P1.Y are these two data fields, but we refer to the name of the object P1.X and P1.Y or P2.X or P2.Y, not the name of the class. We don't say point.X or point.Y. Now we have been saying that in our more simple examples. And remember, that's why we use the static keyword, because static allows us to execute code in a class, even though we don't even actually have an object of the class. But now we do have an object of the class. So P1 is an object of class point. If we want to output the value of the X data field, we would output P1.X or P1.Y or P2.X or P2.Y. And this might make a little more sense too when we get into the code. But any questions so far on that? Okay. Okay, then the other call out here, we can have our point class like this. That's perfectly legit as a class, but there's nothing there to actually run. So we can write a program with a main method and use this class and create objects of type point and then use the code and run it. But until we have a main method, there's no program to run. So in this example, they create public class point main, and then inside the class, they create a main method. So that's, now we have something that we can actually run and execute. And in the main method, they create object point P1 equals new point, and they set P1x equal to 7, P1y equals to 2. And this line here, you know, at first this might look a little confusing. Let me go over here like this. Okay, so, you know, they have point P1 equals new point. So at first that might look, you know, a little cryptic. It's really not much different from saying int I. So here we declare I, and what is I? We'll look to the left, I is an integer. So here we're declaring P1. Well, what is P1? Well, look to the left of it. P1 is an object of class type point. Any questions about that?
So can we regard point as a data type?
No, it's a object. It's an object of class point. What does the new point part mean? Where's the parts? What do you mean by parts? What does the new point part mean? Oh, so new is just the keyword to allocate memory for this. And we saw that with the simple arrays where we say int brace brace my array equals new array. It's just a keyword to allocate memory when we're creating objects. And we'll go through some code examples of this that might make a little more sense. And this part gets into more of a, it's honestly a little bit more like philosophy, because this object-oriented stuff, it's really a lot of design, kind of, and structural design in a way. Okay. So this is kind of more of the same code, but again, public class point main, beginning of our class. Here's beginning of main method, public static void main. Point p1 equals new point. So we're creating a new object named p1 of class type point. And then we set p1.y equals 2. Then we create a new object p2, set p2.x equals 4. And then they're just outputting the values. System.out.println, p1.x, add a comma, and p1.y. And again, we're going to look at code examples and Eclipse of this. This, skipping around a little bit, they're just calling out that when we this is a bit random here, but so if you create a new array object and you don't populate the values, are set to null. Maybe I lost my track here, but I don't know why they're bringing this up here. Okay, let me move on. Okay, methods. Let me find a better example here. Well, I think my examples in Eclipse are a little better, but let me walk through this. So here's our same point class. So public class point. And we have two data fields, int x, int y. Then in the same class, we can have a method, a related method. So here is public void draw graphics of G. So it's bringing in a graphics object, and it's basically drawing some graphics, ovals and strings, using the X and Y coordinates. But the main call out here is just note how we can group methods with the data fields inside the class. So here we have public class point, we have a couple of data fields, and we have one method. And we're going to talk more about this in the coming weeks, so don't worry if this seems like a lot of new stuff. I think okay, constructors. Okay, there's a special type of class method called a constructor. And a constructor gets called automatically when we create an object of the class. So think of it like, you get in your car and you turn on the ignition and someone doesn't have their seatbelt on, so the car starts making an alarm dinging, right? Because you don't have your seatbelt on. It's kind of like that. This is stuff that gets fired off automatically every time we create an object of the class. And the constructor method has the same name as the class itself. So here with our point class, the name of the class is point, public class point. And down here inside the class, we have a method called translate. So, it's doing, whatever public void translate. It takes 2 parameters. It does some calculations, that's fine. But the method up here is named point. So public point. So right there, we know this is a constructor because it has the exact same name as the class itself. So every time we create an object of a point class, this method gets called automatically. And typically what the constructors do is like initial setup or kind of like overhead stuff. So for instance, with these X and Y coordinates, every time you fire up the program, you might just want to say, well, before we get started, we want to set X and Y equal to 0. Or in this instance, there's 2 parameters, int initial X, int initial Y. So these 2 values get passed in and they get put into the X and Y coordinate. So basically, when we create a point object, we can say, okay, create point P1, and I want to set the starting position equal to 5, 5, or what it's like setting the initial values. So that's what the constructors do. Or, sometimes if you're at Starbucks and you buy a Starbucks card and they say, well, when you buy the card, you have to start with like $10 minimum balance on it. We're not going to sell it to you with the 0 balance. It would be that type of scenario. So it will set the default values. And we'll talk much more about this in the coming weeks because there's a lot more to this too. But for now, just kind of know what a constructor method is. So any questions about that? Okay. This is kind of more of the same. So they're creating 2 objects, point P1, point P2, and so point P1 equals new point, and they pass in 5 and 2. So those 5 and 2 values would get passed into the constructor method. A class can have multiple constructors. Hold that thought for now. I'll talk about that in later weeks. The reason we would create multiple constructors is so that we can have different numbers of parameters. So maybe classic example might be we have like a new hire method for hiring a new employee. And maybe when we have a new hire, we know their first name, last name, social security number, and date of birth. So that might have all those parameters in the constructor. But maybe we don't know any of that info. So there may be a constructor where everything just gets, all the data fields get set to null or unknown, something like that. Okay. So encapsulation, I think I'm going to hold off on these topics until later weeks. This gets a little more advanced. Yeah, I'm going to hold off on the rest of this object-oriented stuff and go into some source code now. But any questions before I move over to Eclipse? We'll come back to these slides too in the coming weeks. Okay. Okay. I feel like I've been doing too much talking here, but okay. I'm debating here. I'll start with this program. Okay. Okay, sorry. I'm first I was debating, but I'm just getting my bearing on this. Okay. So this program is this is kind of a old school terminology, but it's called address book. It's basically a contact list. So if this was 1980, it'd be a Rolodex. In 2021, it's your contact list in your iPhone, basically. So a list of people, probably a list of like a directory, like list of phone numbers. It could be adapted to be a roster for a sports team. Really any list of people. So I'm going to start with the person class because I think this is maybe the more more simple class in this program. So here's class person, and again, right now we don't have a main method that we can run, right? So this is just a standalone class as of now so far. And you can still hear me, right?
Yeah.
Okay. So, class person, and here's a data field. So private string name. Don't worry about private for now. That's just a access modifier like public or private. The important thing is data type is string, and the name of the field is name. It really should be first name or last name, but this is kind of simplified. So just private string name. Then there's age. So private int age. And that is a good field to use as an int, because maybe you're doing some kind of calculation to see if they're above or below a certain age or whatever. And then there's private char, gender for male, female, whatnot. So, and then here's our constructor. And so again, we know this is the constructor because it's got the same name as the class itself. So class person and public person parentheses. So this is the constructor. We'll talk more about the keyword this in the coming classes, but this just says the fields in this class. So not given, 0, and U for undefined. So these coincide with name not given, age 0, gender undefined. So basically we don't really know any data values, so he just sets default values for this. And now here is a second constructor. And for this one, this gets called when we do know the data field values. And we'll talk more about this. This is called method overloading, where we declare more than one version of the same method. So they're both named person. So that's method overloading. And because they're both the same name as the name of the class, they're constructors. So it's kind of mixing two things here. But in this method, in this constructor method, there's a parameter name of type string, and there's a parameter age of type int, and a parameter gender of type char. And so you notice these parameters coincide with the three data fields in the class. So if we create a person and we know their name, age, and gender, that gets passed in, and it gets the values passed in get set to each of the data fields. So age gets put in this dot age, name gets put in this dot name, gender gets put in this dot gender. If we don't pass in any values, then this constructor gets called, and this happens automatically by the language. And then the values get set to default values.
I have a question.
Yeah.
So couldn't you just have, or the program itself, couldn't it just have basically set the values with it when you declare the variable itself? You didn't have to write another constructor. So you just have one constructor and then know this statement, all that. So like, what's
So
the
you mean
purpose
like,
yeah, like what's the purpose of having a second constructor, like the one with where you just set the initial values? Like you could have just set it when you declare the variable itself, right?
well, the scenario would be, let's say we're using this for a baseball team roster for Little League Baseball. And they say, oh, the season opens April 1st, but let's get the registration system up and running. So, create all the teams, and team, the team Phillies, like team, if I can spell, how do you spell Phillies? Phillies equals new team. So that creates our new team object from a team class. And then we might create, person P1 equals new person. And then similarly, 30 more of these, P1, P2, P3, etc., right? And so our team, maybe we know the name of the team. This one's Phillies, and we have 30 placeholders. Like that's all they are, placeholders. P1, P2, P3. These are the people, but we actually don't know who's going to register. So then it would use this constructor. So name is not given, age is 0, gender is undefined. But then when registration opens up March 1st or whenever, then it would get called like this: person P1 equals whoops. This is like pseudocode kind of. This probably wouldn't compile, but Bob 12 male. So like now these are actual people registering. So when the person objects get created like P1, we have actual data values to pass in. But then when we create the next person, so the next one is P2, but P2 is an object of the same class, person. So when P2 gets created, now it's Lee, and he's 11, and let's say that's a girl, female. So it's different data values. It's a different object name, but it's the same class. So these data points would come in and get populated into these values. But the class itself is just a shell. It's the object. When we create an object of the class, now we've got specific data values to put into the data fields.
Yeah, so I get that part. I was just talking about the first constructor. So the first constructor, you said, just initializes those variables within the class, right? Yeah. So could you just have taken out that constructor and then put not given? And so string name equals not given, int age equals 0, and char gender equals you. Like,
up here?
Yeah, so you could just initialize them right there, right? Instead of using a whole different constructor, or like, what's the point of overloading the constructor, basically?
So what you just said very well may work,
Mhm.
but this is cleaner because presumably sometimes we'll have data, sometimes we won't. So, but whether a constructor is going to get called whether we like it or not when we create the program. If we don't pass any data in, it'll use the default constructor. If we do pass data in, then we need to make a custom constructor. But that's kind of at a later point than here. So we could probably initialize these to default values up here.
Mhm.
But if most of the time we'll be passing in values, it'll just be then overwriting those values. So it kind of, a lot of this stuff comes down to design considerations, kind of.
Okay. All right.
Yeah, and we're usually after kind of the I don't know, kind of the cleanest design, most efficient design that makes the most sense. But as we get more into the object-oriented stuff, there's like a million different ways to design it too, really.
Yeah, that makes sense.
Okay, and then so the rest of the methods here are set and get methods. And again, we'll be talking more about this in the coming weeks. So don't worry if this is like a lot to consume at once. But let me try to give you the general concept of set and get methods. So notice that data fields are private, but the set and get methods are public. So they become like the gatekeepers of the data. So because the data fields are private, other classes cannot access these data fields, but they can access the get and set methods. So what the get and set methods do is, so a get method, all it does is return the data field value. So get age just returns age. Get gender, it just, if you call the method get gender, so if we call, P1 dot get gender, it'll just return the gender male or whatever. The set methods don't return anything. The return type is void, but we pass the data values into the set method, and these methods take that value and put the value into the data field. So they're really kind of like guards or gatekeepers of the data, because we can control who and how and when the data is accessed or updated. One example of this might be, let's say this stores phone number, and it stores phone number, it's just raw data. So 206 325 4444, right? It's in the database or something, it's just raw data. But we might have a get method like get phone number. And get phone number will be a public method. It'll access the data field phone number, and then it will print it out, right? Well, there may be settings where some people might want the phone number to output like 206.325.4444. Other places may want it to output parentheses 206.325-444, stuff like that. So the data, the raw data in the private data fields would just be raw numbers, but then the output formats would be controlled by the get methods. Does that make sense at kind of a high level? We'll talk more about this through the quarter. And if you wanted to simplify this code, you could basically skip the get and set methods and just make these data fields public, and you wouldn't need the get and set methods. The get and set methods are just kind of good design for now.
So basically, I'm trying to figure this out. So for the private parts, oh, so basically you're just saying the private part you put in the raw data, so like the 206354 or whatever the number, and then the actual public parts, it just changes that to the format that you need.
Yeah, it changes the format, or it could do other things too. like so for the for the set age method, so now we're setting the age, right? Well, maybe this is some kind of store value card for like a bar, a pub, you know, to buy beer. So there you might add a validation here saying, you know, if age is less than 21, output error message. So it just allows an opportunity to do all sorts of checks. Maybe it's a logical data check, maybe it's a format change, anything you could do, because without that, if these data fields are public, another class could just say, oh, you know what, p1.age equals 15. I mean, there'd be no controls over who's updating the data, right? So the get and set methods provide kind of like a layer of security around the data fields.
Okay, got it.
And we'll talk about this through the quarter too. Some of this I'm getting probably a little ahead of myself, but I'm just explaining. It is a good example, though, I think, of of the methods though in the class. So that's our person class. So class person, data fields are name, age, gender, couple constructor methods, and get and set methods. But for the most part, this is a pretty simple class. Class person, it has 3 fields: name, age, gender. Okay, then I'm going to touch upon this class. So class exercise 1024. To make a long story short, this is basically the main method. So there's 3 classes in this program. This one, exercise 1024.java, addressbook.java, and person.java. So we walk through person.java. That's basically the person object that's used for this contact list. This class, for the most part, it's the main method. So this is what runs when we run the program. And I'll kind of come back to this in a minute. And actually, amazingly, if you look at this, the main method is 2 lines of code, is all that's in the main method. And then it's got a while loop, and this is operating like a menu. And actually, before I go into the address book code, let me just run this so you can kind of get a feel for what this program is even doing. This is using the pop-up boxes. Don't get too concerned about this. It's just an alternate output to using the console output, and I can show you how to use that, but don't get too caught up in it. It's kind of a side thing. Okay, so menu option: add, delete, modify, or search for persons. I'll do A for add. So that was case insensitive because it took lowercase a. Okay, please enter. What did I just do? Please enter the name Bob. Age 20. Gender male. Oh wait, so that is case sensitive, so it needs uppercase M. So M. Okay, so person was successfully added. So it just created a person object and added them to an array of person objects that we're going to look at shortly in the addressbook.java. Okay, I'm going to add again. Lisa, enter age, also 20, enter gender, female. Okay, one more. Add what's another name? Okay, so now this has created 3 person objects in an array. So now I'm going to do search. Please enter the name to search for. Search for John. It says entry found. John is 21, male. Okay, so I'll cancel out of this. So that's all it's doing. It's prompting the user to enter the 3 data fields that the person class has: name, age, gender. It's creating the person object and it's adding them to an array, which is the contact list. So now let's look at addressbook.java. So, okay, here we go. Package, chapter 10. Here's the beginning of our class. Class address book. So it's got a couple fields here. Constant field of 25. I think that's the default size of the array that they're using. It uses a not found constant of -1. They're using this. This should almost be a Boolean value, but they're using this to signal if someone was not found during that lookup, it returns -1. But right here, so here they're declaring setting equal to private. They're declaring an array. We know it's an array because of the brace named entry. And it's an array of person objects. So this is a simple array that holds objects of the person class. So it's just going to hold a list of people that we input. So that's really at its core, that's all that's going on. So here's the default constructor. It's got the same name as the name of the class. So public address book, this dot default size. This exercise is a little more advanced than I'd prefer for where we're at right now, but I did want to kind of show you an example of both classes and the arrays. And again, we're going to be talking about this stuff for the next couple of weeks, so don't get stressed out over this or anything. Here, public address book int size, it passes in the default size and it creates the new array of persons of that size. Here's the add person array. So here, entry at position count, add the new person, they increment the count by 1. This deletes the person. I don't want to get too in the weeds here about how it's deleting them. It's actually kind of a goofy design because it's a simple array. So it's not, delete is somewhat of an ambiguous term here. It's more like negating out the data values. And then here's the search method. Now, so there is something I want to show you with the search method. So there is, okay. So there's a method here, find index, which I think the search method calls, isn't it? Find index. I thought the search method calls the find index method. String search. Well, in any event, this is what I want to point out. When we're looking for the person in the array, we can't just look for the particular person object. We have to search for we have to search on a field of the object. So if I create an object and I name the class object John, I can't just look for the person object named John. I'm looking for the person object whose string name data field equals John. So in the search method, we're looking at, here's the array of people objects. Entry, it's called entry. Location is the index value. right? So here's the array at address location LOC. So when we're there, the code is kind of like holding on to the person object. And then we call dot get name, and that will return the name value of that object at that position in the array. And then we can check, does that equal John, yes or no? So when we're at this location of the array and we call dot get name, it'll be holding on to the person object, and then we call the get name method that's right here. And this method says, okay, return the field name. So it jumps up to here, it goes to the name field, and it returns this value, which may or may not be John. And then this method here determines if this is true or not, if that equals the name we're searching for. And then if I go back to this, the main method, here in this constructor method, it creates the object. So my address book equals new address book is an object of the class address book. So to kind of illustrate this, we could create two objects of the address book class here. So, if we wanted to, we could have, for instance, a personal contact list and a business contact list. So we might create a second one, like my business contact list equals new address book. This is airing out because I haven't created the corresponding field names and so forth. But my point is, it's not a one-to-one relationship. Address book is the name of the class. This is the name of the object, but we can create multiple objects of the class, just like we created multiple person objects of the class. So I covered a lot here. We're gonna go through this more in the coming weeks. The other thing I'll point out, so I created an assignment here, but we're gonna do it next week in class on Tuesday. So I published it. So like if you want, you can start it, but we're basically going to do it like in class. So this grocery item list, if you go to the code sample section, there's grocery item order and grocery list, but there's no main method. It's very similar to this address book code. The grocery item is kind of like the person class, and like the grocery list is kind of like the address book class. And then but there's nothing to run. There's no main method for it. So in class, we're gonna write the main method together, and then that will be the main program that runs and uses basically creates a grocery list of grocery items. So you can look at that if you want, but basically in class Tuesday, we're just gonna literally walk through it. It'll be a programming assignment, but if you follow it, by the end of class, we'll be done with it, and you'll be done with that assignment. Okay, so I think that's all I'll cover for today, because that's kind of a lot too. But this is in, let me review these chapters. So chapter 7 is arrays. And then start reading about classes. We'll cover classes more. And then beyond classes, so week after that is like file processing and error handling. So reading and writing to files, and then using try-catch blocks and insertions. And after that, we'll talk about inheritance, which is extending classes. That really gets into the object-oriented stuff. There's a buffer week there that I'll see how it goes. And then we get into the last week, which is the presentations of the extra credit video game. And then it's the finals week. So again, no class this Thursday because it's like a school holiday. Next week, Tuesday, I'm gonna have to start class late at 7 o'clock because of my airport trip. And then next Thursday, we'll have the guest speakers. So just keep making progress on the homework. And just ask
Professor.
me if you have any questions. Yeah?
Could you talk about the final exam a little bit?
Yeah. And then I'll stay on for a few minutes if people have other questions. So the final exam, it essentially covers all the material in the chapters that we're covering in the textbook. So if we cover the chapter, for the most part, those materials will be on the final exam. I can show you next week. I can show you a more specific list of the topics. It's a common final exam, so all the different there's multiple sections of this class, and they're trying to standardize it a bit. So each instructor from each section contributes about 4 questions to the exam, and then they pool them all together and then create one exam, and all the different sections take it at the same time. So let me put it this way. My teaching style, let's see here. I'm gonna okay. Stop recording. Okay, this is my commentary, so I'm gonna stop the recording. When I give exams in the past, I would have them open book, open note, and I would tend to make the questions more try to make it stuff that you couldn't really Google. So like, here's some code, what's wrong with it, or write a class diagram for the following scenario. And the scenario is the Seattle Mariners have a new employee team roster system. And so how would you design the classes and methods? Stuff like that, more about the theory. Some of the other instructors are a little more grounded in the specific code. So they would tend to write questions more like, write a method that sorts the values in the array in ascending order. So something really concrete like that. And they're also like really worried about cheating, which is an uphill battle with the remote content on Zoom and everything. And we're not in person. So all the sections take the exam at the same time. I believe they use the Lockdown browser. So the Lockdown browser, it doesn't let you open up other windows. I don't think it lets you go to other websites. You cannot copy and paste. Some of that I think is good. Some of it I think is kind of a goofy losing battle. Because realistically you could still Google stuff on your phone and stuff or another computer. It just restricts how easily you're able to like copy and paste an email and stuff.
Yeah, someone asked about camera, and if it has camera, I hope I can, rather than going to Lockdown browser than going to Zoom. I think I prefer Zoom. That is feel better. I don't know.
I wasn't aware of it using I don't think it uses a camera. I've never seen that in the past.
So for the for the camera thing, just like because I have a second question, but for the camera thing, I had to do that for chemistry, and it wasn't too bad. But it's kind of stressful when it's like, oh, he's just watching me, and he's gonna think that I'm cheating, even though I'm like, just.
You mean like the instructor is watching the video?
It like records you or something. I don't really remember, but it like records like just you taking the test, and if your like face is out of the thing, because I dropped my eraser one time during a chemistry final, and I got really worried. It's just stressful overall.
Yeah,
but,
I voted against using the lockdown browser. I think it's goofy. The other thing that's I'll check on this for you. I really don't think it includes a camera.
All right.
I'll check on that.
Really quick question, second question. It was if there is a lockdown browser, you know, and they don't like, you know, are we just supposed to like, if it asks us to code something, are we just supposed to do it like correctly the first time? Because so far most of my code has been like, you know, trial and error, and most of the time it doesn't work like the first 50 times. So it's like,
well, so well, let me put it this way. I really I don't know. How do I explain it? So not at Bellevue College. I've taught at other colleges where they literally had like math professors teaching Java that had never coded Java. And so they brought it, you know, a really academic focus to it. Whereas like, I try to think of it like, well, when you graduate and you're working in an IT job, you know, how are you going to use this, right? There's certain stuff that you don't need to memorize because you just look it up. So, so I would design my questions a different way. I get that they want to standardize the sections and have this standardized exam because I think the different sections and different teaching styles started to kind of stray apart. But here's what I do. They mandated that the final exam has to be worth something like between something like 20% and 40% of the grade. I basically made it the lowest. So it's 20%, which is like the absolute lowest that they require. And then I give you like 5% for like attendance participation. And then there's that extra credit assignment. And even though each instructor contributes different questions, at the end of the day, I'm the one grading. Like, there's no one instructor that grades all the exams or all the sections. Each instructor still grades their own section. So basically, I've minimized the weight of the final exam as much as I can because I don't really like this standardized strategy per se. Does that make sense? So, for instance, I've had scrolling all over. So, I've had students that may have had like an A in the class going into the final, and then maybe they kind of don't do that well in the final. They get like a B minus, but because of the 5% for attendance and the extra credit and the fact that the final is only worth 20% of the grade, like they still end up getting an A in the class basically. So, so I've done what I can to kind of minimize it and put more weight on the assignments, if that makes sense. But I'll find out about the video. I wasn't aware of that at all. So
yeah, no, I think there's like options where it's like, you know, sometimes they do the video, sometimes they don't. I think it's just kind of dependent on
Yeah,
like
so
who.
for me, I went to over the summer, I was taking classes at South Seattle, and they had this thing called Honor Lock, and it would it like limits everything that you were talking about, like copy and paste, and it makes sure that you can't leave the screen. But then it also requires you to have a webcam, and it tracks your eyes. So that was very stressful.
yeah, if I have any, I don't think there's a camera option, and if I have an option to veto that, I will not use it. I will say, you know, certain stuff, I think there's nothing wrong with Googling something or looking it up because that's what we do when we're at work. I mean, you can't memorize anything. The key is not knowing the answer. The key is knowing how to find the answer. But so at a different college, I had people find final exams from previous quarters and previous years. And I would have the same type of question on my exam. Like, I don't know, you know, what's the difference between, is the following search method or sort method selection sort or insertion sort? Well, the question would look 99% similar to the question asked the previous year, but I would switch something up. Like the answer would be 12 instead of 10, or the answer would be B instead of A or whatever. And it was so obvious people that were cheating because like they would literally write 2 + 2 = 5 because it was very obvious that like maybe the answer the previous quarter or the previous year was 5 and they didn't even read the question. They were clearly just writing down, answers from a previous exam copy they got. So I would highly warn you against that because like a lot of instructors are really they know what's available online and stuff, and they'll make just subtle changes so that if you are using a previous copy of the exam, you might not even realize that the questions actually changed like ever so slightly. So, looking at a previous exam like that, it might be a good study guide to give you an idea of the types of questions, but I would really warn you about that. The other thing too, and this is advice for all your classes, if it's asking you to write something unique, like unique code, and it's code where there's 101 different ways to do it, and 10 different students, all submit code where the variable counter is the letter M, and the variable name for last you know what I mean? Like the unique variables like all have the same name. That becomes really obvious too when people are like cheating and using the same code. This question, do you think we'd be able to use Eclipse? I'll check. I don't know if like the lockdown browser even lets you open Eclipse. I can double check that. Does anyone know if it lets you open other applications?
I don't think it lets you open up anything at all.
I think you kill all the application once you enter the quiz.
Yeah, it like closed me out of Discord and stuff for chemistry and like what do you call it?
Yeah, see, I don't like that because like when you're writing code for real, you'd be in Eclipse, and if you write something wrong, it immediately gives you the red squiggly line to tell you it's wrong, and you can hit dot and it brings up so it's just not realistic. I mean, I had a few coding interviews where I did terrible because they want you to write code on the whiteboard, and it's like, well, that's not how people write code. You write pseudocode on the whiteboard, but you don't write actual code.
Yeah, because like I kind of spend 3 hours staring at my screen at like a squiggle, really confused, and then I'm like, oh, so that's what I need to do. But like if I had to look at a screen for 2 hours and look at the same code over, I don't think I would have been able to like find that because it's like you miss one of those little tiny brackets and you kind of fail your whole code.
So I think I have to double check. I think one of the categories I have for the exam to write questions is conditionals. So maybe that's like if-else statements. So a question I might write might be, I'll write the code, and then the question might be like, if the input is 10, what's the output? And then you'd have to go through the if then else clauses, just reading it with your eyes and determine what the program flow would be. And, would the output be, Seattle or Tacoma or Portland or something like that.
Oh yeah, talking about like reading code. So about the last quiz, I was going over my answers because I felt like I did something wrong for one of them, and I don't know. I don't know if I missed it the first time, but was that a typo on here? Let me see. I don't know if it was question 5 or not, but one of the I's was capitalized, and I don't know if that was like one of the errors you wanted us.
Oh, I remember that. I don't think I took points off. I think you got that right, but that was a typo. I think that was like the auto format in Canvas made it uppercase I automatically.
Yeah, wait, let me see really quick.
But I think I gave you credit for that because it was a good catch actually. That actually would have aired out. So
quiz 4. I don't think I've gotten my stuff back for that, but I don't know if you mean like that's like for future. But yeah, that was my question.
That was a typo, I think.
Okay, cool. Thank you.
By the way, are we gonna have like a practice exam, like where we can see like what's gonna come, maybe as general?
Not really. In a sense, the quizzes are kind of a practice.
Okay.
What I can do though, to practice the lockdown browser, I can give you a simple quiz and use the lockdown browser for the quiz just so it's actually kind of a good dry run to get that worked out, you know, on your system. But you know, again, I've weighted the final exam the lowest allowed percentage, and then you have extra credit and you have the 5%. So, you know, unless someone completely bombs, flunks the final exam, you're probably fine. You know?
Wait, I'm sorry. So we're gonna code without Eclipse on just like blank space.
Yeah, it's in Canvas. Like the exam is like just like the quizzes are. It's in Canvas.
Oh, that kind of sounds impossible though.
Yeah, I don't write questions like that. And a few of the other instructors do sometimes write them like that, but I'll see what I can do to minimize it. I know it's kind of crazy.
I have a quick question.
Yeah.
It was kind of in the last quiz, the quiz number 4, but in terms of like else if statements and if statements, can you end on an else if, or does the last thing have to be an else statement? So like you can have like an if, else if, and then can you just stop, or does it you have to end with an else statement, correct?
You can kind of do either. I mean, the bigger issue is do the if conditions cover the full range of possibilities, because you don't want a execution path that results in no return value if the method is supposed to return something. So, you know, like you can't have a method where it returns an integer, and then the method says, you know, if it's January, return 1, if it's December, return 12. But that's all it says, and then all the other ones, like nothing gets returned. That would error out, you know.
Okay, because I think when I was trying in Eclipse, if you're like returning a value, if the method requires something for you to return, I think you have to write an else statement, correct? Because like you have to return from every like aspect of the if statement, so you wouldn't be able to else if.
Well, you can have if statements without an else clause. I think the issue there was if you say if month equals January, return 1, and you stop it there, you're not covering for the other months. So the else was to cover all the other months not mentioned. So it would work if you said if month equals January, return 1, if month equals December, return 12, else return 0 or something.
Yeah. Okay. Yeah, because Eclipse like wouldn't let me run unless I have an else statement.
Well, it may just that's interesting.
Probably
It may
just
just be the way it was written.
Yeah. Okay.
Just another quick question: is there gonna be such thing as like grade curving, maybe?
As what?
Grade curving.
No.
Okay.
So, and that typically helps people. So, you know, I've had classes where the class average was an A-, if not an A. And then one student got a D. I think he actually wrote me like a really bad review too, which was funny. But like he literally did like none of the homework, and it still baffled me. I'm like, well, how did he expect to pass the class without doing any of the homework? So I think sometimes some things might be a lot of work, but if you do the work, I would say I grade pretty easy. But you have to do the work. The biggest thing that's going to hurt your grade is just not doing an assignment or missing an assignment. You know what I mean?
Yeah. Sorry. Yeah. Are we done today? I mean, I just have a question about the homework for today. That's due today, and I just don't understand something, and I wanted to screen share and show you.
Okay, yeah. So that's it for today. Remember, no class Thursday, and then I have a few more minutes if people have questions, specific questions about the homework and stuff. So. So, okay, have a
Yeah.
have a good week too. It's supposed to snow apparently like a foot on Thursday, so be interesting.
Can I screen share now?
Yeah, I try it. I
Thank
don't
you,
know if I have that setting turned on, but go ahead and try.
Thank you,
It's
Professor.
turned off.
Thanks. Oh, it doesn't let you?
Yeah.
I'll make you host and then you'll be able to screen share.
Okay.
Okay.
Hey, Professor, sorry, really quick question. Do you have
Yeah.
any policy on retaking quizzes?
Not generally, but just send me a message and let me know what's going on and we'll work it out.
Okay, thank you.
Is it done yet?
Yeah, you can go.
Okay. It's still disabled.
Oh, really?
Yeah. Host disabled participant screen sharing.
I think you kind of
Um,
have to restart the session.
Well, there's an option. Whoever's host, if you look at the bottom taskbar, it says security. If you press on the security, and then there's an option for allow screen share. I think.
Oh, you're right.
Yeah.
Yeah. Oh, then can you right click on me and make me host and I'll turn that on? I forgot about that. Thanks.
Oh, okay. Wait,
think
me? You made me a host. I don't think that you did that.
Yeah, I think you are.
I am.
Or who's talking? Is it
Yeah,
Dinara?
you're host right now.
Yeah.
I'm
So
the
right
host.
click
Oh,
on me and,
okay.
and say make host.
Did I make it a host now? No.
No, not yet.
No.
Oh, okay. Shall I just go out? Chat, replace pin, hide non-participants. That's all I can see when I.
Well,
click
either
on
way,
it.
you're still able to share screen right now. Try it.
Oh really? Oh no,
Yeah.
I can't.
Really?
Yeah. Wait,
I
I'll
don't know.
actually.
Yeah, press on.
Let me
press on the
turn
button.
on my camera. Here. Oh, now I can. No. Okay, never mind. Yeah, it's showing like host disabled participants.
Yeah, I
screen
just try
sharing.
to share and it says host disabled.
Okay,
Wait,
here,
but
can
you're a
you
host. That's weird.
can you right click on me and make me the host again? I'll try to change it.
Okay. Oh no. Do I do this? And then there's only
Yeah.
chat, replace pin, hide non-video participant.
Press on the
That's all
three
there.
buttons. You see?
Oh yeah, the three at the top right
Oh,
corner.
okay.
Yeah, though.
Yeah,
Oh.
that's what I'm pressing on.
Oh, weird.
That's really weird.
Well, it might be quicker. I could just hang up and call back in.
Yeah, okay. Let's do that.
All right, I'll
Bye.
connect right back in.
Okay.
All right. can do that. I would just do dot star.
Okay.
It doesn't take a lot
okay.
of memory, and there might be other stuff that you need to use.
And then I did scanner, and now I'm doing first and last name, string name, scanner, and then it shows up like the value of the local variable name is not used.
Yeah,
I wonder why.
that's just saying you're declaring a variable, but you haven't yet really done anything with it. So that's not a problem per se so far.
So do I like call a parameter now here?
This is the resume builder one?
Yeah.
Oh yeah.
So okay, can I make it like an array-ish, write down like name, contact, school, major, year inside this bracket?
So I would make each of those. So the plan was to make each of those separate methods, and then you would return. Well, you would either just print the value, but what preferably you'd return the value as a string, and then your build resume method would call all of the other methods and then output the results all together. So it outputs as like a resume. Otherwise, if the individual methods print the data, it would be all scattered. It'd be like, what's your name? And then print your name. What's your school? And then it prints your school.
So it has to be under each like class?
Well, they could be in the same class, but like each category would be a separate method. So you might have a method like get name.
So for example, okay, yeah. I'm sorry, okay. So here I would be do I start like public static and then
string
name? Oh, string, yeah.
Yeah, just like the data type of the
name,
return type.
And then here it would be scanner. Is that it?
Yes. I'm gonna look at my code so I don't misspeak here, but yes. One second. It's like switching gears here.
Do I do this maybe?
Yeah, so the one I wrote, the parameter is a scanner object, and I just called it get input. You could call it kind of whatever you want.
What does this mean?
So your method string name. So the parameter is is a scanner object. So uppercase S scanner. And then you just need to name it. So you could name it like get input or something. So change that S to uppercase S.
Oh, it can be anything.
Well, no, not this. This is a scanner object. Yeah, exactly. So the object type is scanner. But and then the name of your parameter argument is like input.
And
so happens in Vegas.
Like,
yeah.
I don't. So is it
so
like
then,
this?
Yeah. Then you say, enter first and last name, and so then string input equals. Oh, except now, but now you're in Vegas, so it's input dot to string, not scanner dot to string, right? It's the local object name in the method.
You mean like because input is a scanner, I have to convert it to a string?
No, so the parameter is input, and input is a scanner object. So you're passing in your scanner object that's named input. So in the method, you use input. That's the name of the scanner object.
This right? Or
well, you could have
I wonder why this is like red.
So you in your method you want to declare. I would declare a string for the name. So declare like string name, kind of like you did up above, but you want to do it in the method.
Okay. Oh, do
And
I
then
still?
say
Uh-huh.
name. So now you want like name equals get input dot next line.
Okay. Input.
Oh, sorry, slow down. So there you just declare your name variable. So just string name semicolon.
Okay. String name semicolon.
Yeah,
A
that's
new
all
one?
on that line.
This is it.
No,
Yeah,
get rid of equals input. So just string names and then semicolon.
Oh, okay. And then there's no input.
Yeah, erase that. Okay. Then your next line is your print statement. And then now on that line, what is that, line 29? You could have like name equals input dot next line parentheses. So name equals input, your scanner object, dot.
Wait, my scanner, do I change this into input? This.
That you want in your main method.
Oh, this is only in, this is, the scanner input is only inside the public name. Is that
no,
correct?
you're so where you declare your scanner object, your line 21, that should be moved to your main method.
This, yeah, I think it's in my main method.
Oh, okay.
Yeah.
Okay, then these methods are not in your main method. So
to string? Is this?
No, name equals input dot next line. Input dot next line.
What does next line do?
That's going to get the user input and put whatever they type into the name variable.
Okay.
And then you want to return that. So then return name.
Return name. And then there would be println. Wait, I wonder why this is red.
You need a closing parentheses on that line.
On which line?
Oh, do you have system dot out dot print?
Oh, I was just thinking maybe the output should be like next to the question.
I think you might need to close your main method.
Main method. Oh wait, I think I closed it.
No, but like this is a separate method, so you don't want these methods in your main method.
Oh, do I get it out of my main method?
Well, leave it there, but just after line 22, do a ending curly brace to end your main method.
Oh, I have to end my method. Okay, and then
because these are separate methods. Yeah, that's right. And then remove one of those guys.
Okay. Oh, and I do the same thing with all these other stuff.
Yes, exactly.
And then,
now from your main method, you would have like string resume name equals, and then you can call that method your name method.
Oh, string.
But not resume. There. Up in your main method. So go back to line.
Oh, okay.
20,
yeah.
After line 21.
Is this still necessary?
Yes.
Oh, okay. String resume, and I just declare it.
Well, yeah, I would call it like resume name. So string resume name equals. And then do a method call to your name method equals name parentheses.
Okay. And then that's input. Is that it or no? Okay.
And then, sorry, one more thing. And then you need to pass in the scanner object, like a Frisbee. You're passing in the scanner object to use to get the input.
So do I write this?
Yeah, lowercase scanner. Now,
okay.
And then I would just run that, make sure that works, and then you do the same for the other sessions. So those you could just comment those out for now. Yeah.
Yeah.
Now, and just get the one method working, and then once that works, you just kind of use the same format for the others.
Mm-hmm. Oh, okay, it works. Yes.
Oh, did it print it?
Oh, it didn't print it out. I just pressed enter. Yeah.
Oh wait. Sorry. And then so I forgot that. So now on line 23, you just add a print statement to output. We could actually combine these two into one step, but this works. So then just print out resume name.
Okay.
But now in your main method though, what you want to do is
it's in the main method. Oh wait, no, what?
So in your main method, you'd want to call all the sub methods, collect all the data, and then print out all the values, so that when you go to print it out, it'll be like a clean resume format. Otherwise, it'll be like input output, and it won't output cleanly, you know.
So I do the same. Okay. So I do the same thing with all these, and then I go call it from my main method, so it prints out all the information.
Yeah, exactly. And I would do, break it in two parts. So you have you declare your string instead of equal to the method call, like you did on line 22, and do that for all the methods. And then where you print it out, do that for all the data fields in one chunk.
By the way, can I do like this? Maybe like, for example, if I'm doing the contact info here from contact, can I write like contact and scanner after I built the scanner public static parameter? Can it like do this like continuously print out? So
no, because you're putting so your name method is returning the name value and putting it into the resume name string. So I see what you're asking. Could you just do them all in one list?
Yeah, exactly.
That might work.
With just the comma?
I'm not sure actually. That might work. It's not how I would write it, but that might work. You could try that.
So do I like write a new one for everyone if that doesn't work?
Yeah.
Okay. And then that's it? Oh, so like call and okay.
Yeah, so you would do all the different strings with the method calls and then print them all out, basically.
Oh, okay. So I will have like 1, 2, 3, 4, 5, 6, 7 parameters like this. Okay, I see. Thank you so much. Like this is kind of hard to understand. Do I need to focus more on the book or?
And I know it's a little goofy because it seems kind of like overcomplicated, but it's just to demonstrate. It's really to demonstrate the method calls and the parameters.
Okay, I see. Thank you so much. That helped me a lot. Thank you. Okay. I'll stop screen sharing. Yeah. How do I?
Oh, is it down below? Do the up arrow from screen share and then like stop.
Share. Like multiple.
Sorry, it's up above. Is it under the if you hover over the
optimize hide meeting chat.
I think you have to hover over the top.
Okay, okay, I did, and desktop.
Oh, here I can do it myself.
Oh, okay.
Okay.
All right. Thank you so much. Have a great evening. Thank you.
Okay, you too. I gotta go pretty soon, but does anyone else have other questions?
Nope.
Okay, I gotta go help the kids.
Yeah, thank you.
Okay, have a good week, guys.
You too. Bye.
Thanks.